Hey Dr. Grissom, this is Blake, here for the unique dataset assignment. Sorry it's a bit late. Du Bois and I had some trouble figuring out datasets and also collaborating in a timely manner. So Du Bois is handling the classification video and I will be doing regression. So first, the dataset. Our dataset was this servo dataset. So it was multivariate and it had both categorical and integer attributes and only 167 instances, which was pretty nice because the classification dataset we used wouldn't run on my computer. So the dataset information, it was probably used for like translational axes of a robot in their AI lab, and it was a simulation of like a servo system. And the attributes are motor, screw, p-gain, v-gain, and the class. So we're trying to run regression to get the number of the class, basically. And let's see, so a bit more on the data. So we just did the basic, numeric stuff, non-numeric data. We had to encode those two to get them to be numeric so that we could run everything. Randomized it, selected columns and features, labels, and we separate the data normally. Basically all the stuff we already did. So to get into the models, the way Du Bois and I split this up was I did one regression and one classification model, and he did the other one for each. So I chose lasso, and he chose support vector regression. So this was the code for lasso. I gave an alpha of 0.1. I believe that was recommended in the scikit docs for it, and it takes in the normal x and y, which would be df features training normalized and df targets training. We had to do the numpy and ravel. And then the support vector regression was, let's see, just the same stuff, takes in an x and a y, and it was pretty simple. So yeah, I kept it with the default c value of 1, and so the predictions for it, well, this has the predictions and it has the code for the mean squared error because we needed the prediction for each one, so we just added it to an array and then the array spits it out later on. So here are the predictions for lasso right here, and for support vector regression, and here are the actual. And for the formatted results, let's see. So lasso did really badly. Consistently, it did poorly, and it had a super high mean squared error. I'm assuming because of how bad the accuracy was. And it was consistently bad, like oftentimes lower than this. This is pretty good for it. And support vector regression did pretty well, an 82% in the results for the training testing split, and a much lower mean squared error, which is good. So let's see. So I guess the SVR was acceptable and lasso certainly was not. SVR definitely worked better. And I think it worked better because it takes a subset of the data and works with that, and it's a bit more kind of general, I guess. The reason I chose to do lasso was because I thought it would, well, first of all, like looking at that decision tree from scikit that was linked on Trello, I think lasso was the first branch that fit our data, and then it also said that it was like good for non-zero numbers, and we didn't have any zeros in our data. Some values got close, but most didn't. So I figured, hey, this might work out pretty well. Yeah, it did not. It was kind of interesting. I would like to know more of like why this performed so poorly. If like maybe I should have changed the alpha a bit more. I looked into that a little bit, and it said like without the alpha being 0.1, it was a bit more like linear regression. So that's why I stuck with the 0.1. for alpha. And yeah, support vector regression just did way better on this data set. And I don't think there's any other meaningful analysis I could add. So I guess that's all. Thank you.